Welcome to Brain Vision.
So here I have labeled the resistors and the EMFs with their appropriate value corresponding to that variable. So for example, R5 is the resistance of this resistor and has a value 5 ohms. Similarly, this E10, which is the EMF, has an EMF of 10 volts. And for the currents, we have the subscript is such that that's the current corresponding to that particular variable, like that particular resistor or EMF. So I 6.8 is the current flowing through the 6 point ohm resistor, and similarly I 12 is the current flowing through the 12 ohm resistor, and I5 is the current flowing through the 5 volt EMF. You can call this I5 or I10, whichever one you want to pick. So, yeah, so now we apply the junction rule to points A and B, and we apply the loop rule to loops 1, 2, 3 that I have already labeled here, and this will give us 5 equations. And this will make sense because we have 5 unknown currents that we need to solve for, and therefore we need 5 equations for that. So let's start applying the junction rule at A and B, at points A and B. So we have I5 equal to I top plus I6 for junction A, and then I top plus I 6.8 to be equal to I12, because they have the opposite direction. So I top is this way and I 6.8 is like this. So at point B, these two combine to make I12, and therefore this is the relation. So from here, we can solve for I top. So because I top is common in both of these equations. So doing that, we get I5 minus I6, which is I top, equal to I12 minus I6.8. And we can arrange this equation like this, having all the positive signs, plus signs, I6. So this is our equation from those two junction rules. Let's call that equation 1. So we got this equation by solving two equations. And now therefore we have eliminated the variable I top. So we will have 4 equations now because we have reduced these two into one. So now we apply the loop rule. So this is for loop 1. Remember, if you are going from positive to negative inside a battery, there should be a negative sign before that, and if you're going negative to positive in a battery, there should be a positive sign before the EMF. And for current, if you're going along the direction of current, there should be a negative sign before that, and if you're going opposite to the direction of current, then there should be a positive sign for that. So those are the simple rules, and I have applied them, and you can check them if they are correct. Also, it doesn't really matter how you go, how your loop looks like. For example, you can choose this loop 1 to be counterclockwise, and you should be able to arrive at this equation. So this is for loop 1, Let's call that equation 2. This is for loop 2 and this is for loop 3. So let me just write that so that you don't get confused with the equation number. Yeah, and this is the equation that we got from the junction rule. Now we will solve these four equations by the method of substitution, elimination by the method of elimination and substitution. So let's use equation 4 because I find this equation the simplest out of these four. So let's use this to solve for I6. So we will get I6 in terms of I12 here from this equation, and R12 over R6. So since these two basically represent the value that's equal to the subscript, so we can plug that. You can cross check that if the resistance have actually these values. So we have R6 equal to twice of, sorry, we have I6 equal to twice of I12. So now that we have I6 in terms of I12, we can eliminate wherever we have I6, and that way we will be able to eliminate one more variable. So let's combine these two EMFs by adding the voltages. So we have I5 plus I6.8 equal to, so this is equation 1, so I have added these two, so this will be equal to 3I2. So let's call this equation 1 again because these are practically the same. So now we plug that with to the loop 1 equation to equation 2. We plug this value of I6 over here. So we will get I15 minus I5 R5 minus I12 R12 equal to 0. So I have added these two because E5 has value 5 volt, E10 is 10 volts, so 5 plus 10 is 12. And that's why I have written here to be E15. So again we have E12, which is E4 plus E8, and these two add up to 12. E12 is equal to minus I12 R12 minus I6.8 R6.8. So this is equation 2, this is equation 3. So you might get confused as to how this became I12 R12. So basically I have substituted R12 as well in terms of R6. So basically R6 is R12 over 2. So if you combine these two, you'll see that I6 times R6 is in fact equal to I12 minus R12 because these two values cancel out. So that's what I have done in order to make our equations look nice. And you can directly substitute all the values that might be a little bit simple. So yeah, you can do that. So now we have three equations and three unknowns: I5, I6.8, and I12. We have already eliminated two of the variables. So among these three, as you can see, equation 1 is the simplest. So we will use this to, let's say, eliminate I6.8. So I6.8 will be I3 I12 minus I5, and we will plug this into this equation. This has I6.8 here. Equation 2 doesn't have I6.8, so yeah. So plugging this over here, we'll get I12 minus, sorry, E12 minus I12 R12 minus which is I 6.8 times R 6.8 equal to 0. And this is actually equation 3, except we have plugged this over here. So now we have two equations, equation 2 and equation 3. So we will eliminate, let's say we will, out of these two, this one is the simplest. So we will use this equation in order to eliminate one more variable. So let's say we eliminate I5. So we express I5 using equation 2. So from that we have this, and we will plug this into equation 3. So, and then as you must have already guessed, equation 3 will have just one unknown I12, because everything else is now expressed in terms of I12 only. So then we can solve for I12. So doing that, so this will be the final equation 3. So now we solve this equation for I12, which will be equal to E12 R5 plus, and then we need to plug the values of the EMF and resistance, and this should not be confusing at all, because the values of these two variables are represented by their subscripts. So doing that, so E12 is basically 12, R5 is 5 ohms, yeah, and so on. So solving, then we get I12 to be 0.66502, and this is approximately 0.665 ampere. So this is I12, or the current flowing through, let's see, I12, the current flowing through the 12 ohm resistance. So let's write that in brackets. So now we can go backwards and solve for the rest of the currents. So because we have solved for I12, so we need an equation that just has I12 in it. So this is the one. So this has just one unknown I5. Rest of the things are known now. So we will find I5 by using this equation. So doing that, we find I5 to be equal to 1.40 ampere, nearly equal to 1.40 ampere. So this is the resistance flowing through the 5 volt EMF, or the 10 volt EMF. Okay, let's just write 5 volt EMF. So then you have I5 and I12 now. So let's say we can find I 6.8, because these two are already known. So we use that equation, and I 6.8 comes out to be 0.591 ampere. So that is the current flowing through the 6.8 ohm resistor. And then we can find I6. That should be easy, because I6 is just twice of I12. We could have done that just after finding I12. But anyway, so I6 is 1.33 ampere, and that is the current flowing through the 6 ohm resistor. So yeah, and There's one more current to find, which is I12. So let me just write that over here so that I don't need to go to the next page and all the currents will be here. So I top is basically, let's use this equation. So I top is I5 minus I6. So I5 is 1.4 amperes and I6 is 1.33 amperes. So this should be equal to 0.07 ampere. So this is the current flowing through this region from A to B.